Good day, everybody, who are hearing this another beautiful insight on environmental continuous ambient air quality monitoring data analysis. Today, I have taken another interesting location located at Delhi, and I am going into an in-depth analysis of ambient air quality status using continuous ambient air quality monitoring data provided by Central Pollution Control Board at Punjabi Bagh, Delhi. Quite interestingly, I would like to give a preamble before I start my presentation as what is the national status of continuous ambient air quality monitoring stations. There are about 558 continuous ambient air quality monitoring stations in India, out of which there are about 104 manual national ambient monitoring program stations in the country, monitoring in around 334 cities and towns in 28 states and 6 union territories. These manual monitorings are happening at a rate of 2 data per week, 104 samples in a year. 5 years data are reconciled, and non-attainment cities are declared. There are about 131 non-attainment cities declared in the country, for which there is a NCAP, that is National Clean Air Program, has been instituted. So to add on to their capabilities, I want to give in what is the status of a continuous ambient air quality data at Punjabi Bagh. Why I have taken a continuous ambient air quality data? Because it is a finer data, sampling at a rate of 15 minutes per data, 24 hours, 365 days. And the data strength is about 1,440 data per day, 43,200 data per month, and 5,18,400 data per annum with 95% availability. Again, the cost for this establishment of establishing a continuous ambient air quality monitoring comes around nearly 1.25 crores, and running or a operational maintenance cost around 3 to 5 lakhs per month. Being this as the background of the issue, why I should do this presentation and what is the purpose is because these continuous ambient air quality data are very minimally used in this country, and they are only used for air quality index publishing. Other than that, there is no deep analysis or in-depth analysis done with these data to culminate an action plan, to have a mitigation plan to the people of India. So I want to educate the regulators, the environmentalists, the younger generation to understand and also to react to this analysis and to these stations in the country, so that a transformation happens in the country, so that this continuous ambient air quality monitoring stations are put to use for the betterment of the country. So how to put to use is my purpose of my presentation. I start with the problem statement. Okay, anybody's as a common man question, where is the pollution? What is the pollutant? When pollution came? What hour it got polluted? Is it pollution happening every day, every month, every year? What is my health status on this? What is the health risk that I am undergoing? There is a talk and also publishing in the newspaper saying that there is going to be what you call health issue with respect to lifespan expectancy. So these are all are highly spoken of. So I want to take this one data and talk in depth as what is the data saying, what is the data talking about, what is trying to deliver, what action we should take, when we should take, where to take, which direction is the pollution coming from, will be some of my insights into my presentation. Okay, I will go into the presentation and I will try to explain what I saw in this data as we get along. The location is Punjabi Bagh and the provider is Delhi Pollution Control Committee. And the data that I have taken is 30 minutes. And the period of the data is August 2022 till August 2023. I have taken the data for analysis. This is the National Ambient Air Quality Standards, which I have taken, and I have just taken for compliance monitoring for these standards. This is known to everyone. The important point that I always stressed in my previous uh, presentations is this, which is not at all touched again and again. So I want to emphasize the legality of this National Ambient Air Quality Standards, which is not adhered to or not followed by regulators. So I want to make an eye opener to the regulators and also to the common public that please look into this law point, that is 24 hourly or 8 hourly or 1 hourly monitored values as applicable shall be complied with 98% of the time. A non-compliance to 98% of the time needs a legal action. They may exceed the limits, but not on 2 consecutive days of monitoring. Okay, you cannot keep on doing monitoring, and we cannot take any action means the purpose of monitoring will be defeated. So there should be some solution to the monitoring also and some preventive action steps taken, and this should be reflected in each monitoring stations. Monitoring and pollution control need not be changing the monitoring station to a different place and saying that pollution has control. It is monitoring at the same location, see where is the issue, control that issue, and see that the monitoring station reflects on a very good data. Yes. This is a monthly distribution of PM10 and PM2.5 for Punjabi Bagh location. You see, after October, the pollution level starts increasing and it again subsides after June. But the value remains to be very higher, more than 100 throughout the year. That is PM10. And for PM2.5, you see it is 100 and above on an average, slightly around above 60. And it goes above nearly 200 and so, but peak values goes more than 400 to 500. This is the observation from the monthly distribution of PM10 and PM2.5. We still strike to go deeper into it and study what really happened. This is the time series plot of a 24 hours rolling average of PM10. What happened every day? This is where the exceedance class shows. You can see an yellow line here. This shows the exceedance. And you see all the plots throughout the year as it's exceeded. Literally, the law of 98% compliance. I want to go back again and read that. 24 hours or 8 hourly or 1 hourly monitored value as applicable shall be complied with 98% of the time. They may exceed the limits, but not on 2 consecutive days of monitoring. It has exceeded more than 2 days of consecutive monitoring, but it needs action now. Okay. Now, as I've spoken about, these are all the days in that month, from the month August 2002 to August 2003 have exceeded. It has exceeded in August 13 days, and likewise 14, 22, 20. You can go through it. And from which direction it came? It all came from south, southeast, south of southwest, and south of southeast. And the affected area, northwest, north, north of northeast, is predominantly is the affected direction which the public or the society got affected. This is the PM 2.5 24 hours average of exceedance plot of 60 microgram. Previously, it is 100 for PM10. And now for PM 2.5, 60. You see that yellow line which is crossing at 60. And you see it's literally all the months it has exceeded. The time series plot shows very clearly. And these are the days in which exceedance has occurred. And it very clearly shows it's from the month of October to April. The pollution level exceedance are literally very high. And predominantly it came from south, southeast, and south of southwest. And the affected direction is northwest, north, and north of northeast. This is the CO carbon monoxide 1 hour rolling average of 4 milligram per meter cube compliance. You can see the non-compliance for so many months. This shows that there is a combustional source which is a cause or a cumulative factor to this PM or PM10 to be existing in the environment. In later slides, I will try to explain you more detailedly what is the relationship between CO and PM10 and PM2 in combustional sources. The 8-hour rolling averages of 2 milligram per meter cube here, you see that also exceeded, and the two colors represents, one is the original, the blue is the original CO values, and the red is the calculated 8 hours average value, and that also is exceeded. NO2, 24 hours rolling average of 80 microgram per meter cube has exceeded in few days. But most interestingly, if you see, the NO levels are very higher in this monitoring area of Punjabi Bagh. The time series plot of SO2 shows full compliance to 80 microgram per meter cube. The ozone 1 hour rolling average shows slightly exceeding the 180 microgram per meter cube. The 8-hour rolling average of ozone, which is 100 microgram per meter cube, yes, it has exceeded very few days. The benzene, which is an emission outlet from a combustion process of vehicular engines, that has found to be a very high level. The annual standard is 5 microgram per meter cube, and you would have seen that value somewhere around 14 to 15 is existing in Punjabi Bagh, very clearly saying vehicular pollution is existing there. And it is also reflected in some values in CO and high values of PM10 and PM2.5. Now we will see some correlations with respect to windrows and other parameters, so which can show an insight into what happened at Punjabi Bagh. So the windrow shows exactly as early spoken about, south, southeast, southwest is the predominant direction from which the wind has prevailed during the monitoring period of August to August 2023. The PM10 pollution rows also shows very clearly it is south, southeast are the predominant places from which the pollution has been attributed to the ambient environment. The PM2.5 also shows a very similar pattern, more or less like south, southeast, southwest, and southeast direction from which this origination of pollution has happened. These are all with respect to the location of the monitoring station. The meteorological directions which I am saying is with respect to the monitoring situation at Punjabi Bagh. Okay, this is the PM10 percentile rows. So I have taken 3 percentiles, 50th, 75th, and the 99th percentile. The red line shows the maximum value from which direction the pollution came. Same with respect to PM2.5, the directional views from which maximum pollution came. Here, we are going to see a diurnal plot or a plot of 24 hours, which is happening daily for the whole period from August 2022 to August 2023, daily, every 24 hours. I have taken 3 parameters, PM10, PM2.5, NO, and CO. You see after 18 hours, that the blue and the green are PM10 and PM2.5. The yellow and the red are CO and NO. They also rise equally very much, signifying that CO and NO emission are causative emissions from combustion from vehicular engines. So this is the contributing factor in the evening. There is a double peak seen, one in the morning and one in the evening with respect to particulate matters, but not very significant in the morning hours, but very, very clearly significant in the evening hours with respect to CO and NO emissions. Sorry. This is the percentile rows of PM10. And this is the percentile rows of PM2.5, which I have explained earlier. Oh, previously I explained this is pollution rows. This is not percentile. This is pollution rows of PM10, percentile rows of PM10, percentile rows of PM2.5, then the diurnal plot of PM10, PM2.5, NO, and CO, followed by another percentile rows of PM10 and 2.5 percentile rows. So here, something interesting study, I took it up to know what's happening every monthly with respect to CO and the PM10, how they are really relating. After seeing the diurnal plot in the evenings, I took up this monthly what is happening. Very interestingly, it can be seen that from September, it is every evening, it is showing a relationship of CO with particulate matters. December, Jan, February, March, April. From May onwards, this changes. Seasonally, because of temperature and other factors, might be a causative agent for this change in this relationship of CO and particulate matter behavior. This is purely meteorological factors which are attributing this change. But the first peak, what we see here is also showing some disturbances, not very clear clarity with the CO emission. This is also one beautiful information that can be derived. Except for some people, somewhere like December and February and March, there is some relationship of double peak which is seen April, May. But here in June, July, August, I don't see much of the first peak, but at the second peak, that is of the evening hours, more after 21 hours, the pollution levels of particulate matter and CO has a very significant relationship. I did also another study called diurnal plot with respect to atmospheric temperature and CO. What happens when the temperature is lower or higher and how the CO behaves? This blue attribute is the CO. As the temperature comes down, the CO level goes up. This is what one of the inferences that I've drawn. And with respect to time, with respect to the month also. Very interestingly, we can see that as the temperature is lower, the pollution, as the temperature is highest peak, the CO levels is minimum. That is also another information we see. As we see the temperature is more during March, the CO levels are minimum. And as the temperature is getting lower or decreased, the CO levels also starts increased. So this can be due to the cold. Some heating factors are also attributing to this CO level to exist in the environment. PM10 and temperature correlation. So I took a PM10 plot, a double peak plot. This blue one is a PM10 plot, and the red one is a temperature plot. See, you can see as the temperature comes down, the PM10 goes up, and as the temperature goes up, the PM levels come down. So there is dilution happening as the temperature goes up. And when the air becomes thicker and thicker, that without dilution, the pollution level starts increasing. And this changes with fluctuation with time, month, and the seasonal variations. It is for this that I have plotted this and explained as better as I can. I think so better people can understand more with respect to relationship with the temperature and PM10. Because as the temperature goes on, people try to wants to make themselves warm, maybe leading to PM10. And also the food practice in Delhi is also might be an attributing factor because there will be a lot of dhabas and they will be making those rotis and all in open might be also contributing for CO and PM in the environment. This is just a suggestion. This is no correlation with science, but this is the correlation with the data. So this is the peaks, what I found, maximum peaks at what time. This is the year, August to August 2022 to 2023, and the maximum hour in which nearly in the month of August, it is 12 o'clock, and thereafter in September and onwards, it is 21 hours, 22 hours, 24 hours, 22, 23. So nearly 21 to 24 hours, maximum peak is reached and maximum value of PM10 is attained. And The atmospheric temperature with respect to PM10 reaches maximum at these hours. That is more or less in the evening. And the minimum PM10 levels happens at okay. The minimum PM temperature happens evening at around 17 hours, 15 to 17 hours, and the temperature is at the temperature at that time is here shown in this table. So I have taken maximum PM concentration, time, concentration, and the temperature at that time, and minimum PM time where the PM10 levels are minimum, and also the temperature at that time to show some relationship as how this double peak behavior is happening with respect to time and period and months at Punjabi Bagh at Delhi. This is respect to PM 2.5 CO and NO. The same thing which I have done, what previously showed and explained in 10, more detailedly I will explain with respect to PM 2.5 at maximum hours and maximum values, minimum PM 2.5 hours, minimum concentration of PM 2.5, and maximum CO levels at what time and what is the value, and minimum CO level and at what time, what is the concentration, and the NO maximum R and the maximum value and minimum value. This is how I have tried to more detailedly expand with the table. Somebody have the time to even to look into also can look into this detail. I will also publish a paper on this so that people can read through this and also understand. This is the day-night behavior at PM10 at Punjabi Bagh. More or less, it shows that there is no big difference with respect to PM10 distribution with respect to day and night. It is more or less equal. But it's somewhat different with respect to PM 2.5. The night times PM 2.5 are more with respect to day. This is also one inference that we have seen from the study. This is the calendar plot of PM10 to show you holistically throughout the period how which month polluted or exceeded the 24 hours values, or what concentration exceeded can be seen from this gradient color which we have provided here. And this is the calendar plot of PM 2.5. This is the correlation heat map, which shows very clearly the PM10 and PM 2.5 correlate with 0.89. That means is highest correlation. CO and NO with 0.65, somewhat better than a moderate. SO2 and ozone 0.48. Particulate matter PM10 and NO 0.43, the correlation, and particulate matter 2.5 and CO 0.38 correlation. So from this, it can be seen that SO2, yes, it has contributed, but moderately. Industrial attribute is also there for this PM to be there in this ambient air. But more of CO and NO relationship shows that vehicular's attribute is rather a higher attribute from other contributes like resuspended dusts, constructional dusts, and other dusts that can be originated. But this study shows that industrial factor is also there in this pointed pollution at Punjabi Bagh. I did another inclusional study, which I have not done in my previous presentation. It's called health risk factor with respect to PM10 and PM 2.5. The safer level is shown as 0.5. The PM 2.5 annual standards shows about 2.54 times the risk, and the daily PM 2.5 value is 1.66, and the annual PM10 risk is about 3.40, and the daily PM10 is about 2.02 with respect to the risk factor, and safe level is 0.5. So this is the whole, after my detailed studying, I am just culminating the whole thing into a table to explain what is it exactly and what is the risk that the people are encountering and what legal steps has to be taken to safeguard the health of the people, living people at Punjabi Bagh. So 24 hours average threshold is for Indian standards is 100. For WHO standards, I have compared with the WHO standards, which is 50. And the 24 hours average exceedance is 142.88, while that of WHO standard is 165.23. The number of exceedance days is 310 exceedance days. Here it is 359 exceedance days. And the annual average threshold is 60 uh, microgram per meter cube, while the WHO annual average threshold is 20 microgram per meter cube. The annual average exceedance is 142.88, 165.23, and the estimated life expectancy reduction is about 11.43 years for the value that is shown at Punjabi Bagh, and with WHO standards 13.22 years. As per the global burden of disease study, every increase in 10 microgram per meter cube with a reduction in life expectancy of approximately zero point 6 to 1 year, this table has been produced. The same explanation is more predominantly explained for PM 2.5 with the 24 hours average of 60 and also annual average of 40. And it shows an estimated life expectancy reduction of 3.69 for the Indian standards, and for the WHO standards 5.49. So with this, I really thank my people, the enthusiasts, the environmentalists who have really encouraged me to do more videos like this, and also to give more in-depth studies, and also to give more insights into the learning to understand how to take this continuous ambient air quality monitoring in the country in a better way and for the betterment of the public, as these data can take immediate mitigation management and take preventive methods and steps to protect the people and safeguard the people. Thank you.